Section 3.5, point slope form of a line. We're going to start this section in a similar manner to the way we started the last section. And that is, let me start just by developing the formula that we're going to use for this section. A similar discussion takes place at the beginning of the section. Let's talk about a line that has two generic points, and let's call them x and y and x1, y1. Last time we started with an x, y, and a very specific point, the point 0b, on the y-axis. This time we're just talking about 2 points anywhere on that line. And like last time, let's begin by finding the slope. The slope of this line is going to be the difference in the y's over the difference in the x's. In this case, y minus y1 over x minus x1. Now let's see what we can do with that. One thing I can do is clear the fractions. Multiply both sides by this denominator. Multiply both sides by that denominator. That'll clear the fraction on the right-hand side, and my denominator pops up over here on the left. As we've been working these linear equations into variables, with the exception of standard form, we typically see the y shown on the left-hand side of the equation. So let me go ahead and turn this around to have y minus y1 equals m times quantity x minus x1. And so here I have point slope form of a line, because this is the equation of a line that displays a point x1, y1 and a slope m. The plane x, the plane y, those are my variables. And I'll be plugging in for x1, y1, and m. In other words, if I'm given a point and a slope, I can plug into this form of the equation of a line and have the equation of the line that goes through that point with that slope. Here at the beginning of the section, our brown box indicates this same thing. Point slope form of a line of the equation. The point slope form of the equation of a line with a slope m and that passes through the point x1, y1 is this guy right here. Y minus y1 equals m quantity x minus x1. Let's go ahead and jump to the homework and see how we're going to use this to work some problems. Number 6. Number 6, we have the point 2,9 and a slope of 6. The instructions say, write an equation of the line passing through the given point and having the given slope. Give your final answer in slope-intercept form. So at the end of the problem, we need to be sure that our answer looks like y equals mx plus b. In other words, that our equation is solved for y. Well, I have a point. I have a slope. In the previous section, when I had a slope and a y-intercept, it was very easy to get the equation of the line. We plugged into slope-intercept form. Given a slope and the y-intercept, plug into slope-intercept form. Here I have a point and a slope. I wonder, what form of the equation of a line should I plug into? I don't know, maybe point slope form? Y minus y1 equals m quantity x minus x1. Where x1, y1, those are the coordinates of the point that I'm given. M is the slope, and we plug in. Y minus, my y coordinate is 9, equals the slope, m, which is 6, times the quantity, x minus, and the x coordinate of my point is 2. Now at this moment, we have the equation of the line that passes through that point and has that slope. We have an equation for that line, but the instructions said, give your final answer in slope-intercept form. In other words, let's get this solved for y. Distribute the 6. Add 9 to both sides. Add 9 to both sides. And now we have the equation of the line in slope-intercept form. And there's an easy check for this. I can check this by showing that this line passes through that point and has the given slope. Does it have the given slope? Yeah. This is y equals mx plus b. When it's solved for y, the slope is the coefficient on x. This line has a slope of 6 right there. And does it pass through the point 2, 9? Well, plug in 2 for x and 9 for y and see if this gives you a true statement. Is that point, is that ordered pair a solution to that equation? Yes, it is. So this is the equation in slope-intercept form of the line that passes through the point 2, 9 and has a slope of 6. Let's do another one. Let's do number 14. We want to find the equation of the line in slope-intercept form at the end of the line that passes through the point 4, 2 and has a slope of negative 1/3. I have a point, I have a slope. Let's plug into point slope form. Y minus y1 equals m quantity x minus x1. And so we plug in y minus y1, the y coordinate of the given point is 2. My slope, negative 1/3, times the quantity x minus, and the x coordinate of the given point is 4. We have an equation of the line. This equation is an equation of the line that passes through the point 4, 2 and has a slope of negative 1/3. But, again, we're required in this particular problem from the instructions to give our final answer in slope-intercept form. So we want this solved for y. Now don't go clearing the fraction. You're solving for y. Y is almost by itself. If you were to multiply both sides by 3, you'd just be making things worse. We're solving for y, trying to get y by itself. The first thing we'll need to do is distribute that negative 1/3. Watch your signs. Negative times negative is positive. 1/3 times 4 is 4/3. And now, add 2 to both sides to get y by itself. Here on the left-hand side, that does leave y by itself, y equals. And on the right, negative 1/3 x. And in order to add these numeric terms, I need a common denominator. Let me rewrite this plus 2 as plus how many thirds? 2 is 6/3. So now that I have a common denominator, I can see that that's going to be a plus 10/3. And this one can be checked just like the last one. You can see the slope sitting there, and then all you'd have to do is plug 2 in for y, 4 in for x, and make sure that that checks. That's actually not a difficult check. I would encourage you to do that. Let's crank it up just a little bit. Number 18. In number 18, we're given 2 points. I want to know, what is the equation of the line that passes through those 2 points? Well, unfortunately, there's no such thing as point-point form of a line. I have point-slope form now, but I would need a slope in order to use that. If I only had a slope, I'd be in business, because I've got 2 points to choose from for my x1, y1. If I only had a slope, well, there's no problem there. If I have 2 points, I can always find a slope, can't I? The slope is the difference in the y's per difference in x's. I'm going to call the first point my first point, the second my second. So I will plug in, the difference in the y's is going to be 6 minus 5. Difference in the x's in the same direction, 9 minus 8, which is 1 over 1. So this line has a slope of 1. I should be able to find me an equation now. I have 2 points to choose from, and I have my slope. I'm ready to plug into point-slope form. Y minus y1 equals m quantity x minus x1. And it doesn't matter which one of these 2 points you used for your x1, y1 when you were finding the slope. You can relabel them now. Choose either point that you want to plug in to point-slope form. I'm going to choose the one that looks a little easier, the one with the little bit smaller numbers. Although it doesn't matter which point you use, you'll still get the same final answer. I'm going to use the 0.85 as my point to plug in to point-slope form. That'll give me y minus, and the y coordinate of my chosen point is 5, equals the slope. We found the slope to be 1, times the quantity, x minus, and the x coordinate of my chosen point is 8. We now have the equation of the line. However, looking back at the instructions, it does say write an equation of the line passing through the given pair of points. Give the final answer in slope-intercept form and in standard form. Let's go ahead and do the slope-intercept form. So let's go ahead and solve this for y. Please don't say you're distributing that 1. There's no sense in that. That's overkill. 1 times the rest is the rest. There's no need to distribute. Trying to get y by itself. Add 5 to both sides. Add 5 to both sides to find that y equals x minus 3. What an easy check for this problem. Plug in this first point. Does it check? When x is 8, is y 5? Yes, it is. Plug in 9 for x. Do you get 6 for y? Yes, you do. So this is the equation of the line in slope-intercept form of the line that passes through those 2 points. Now your book also wants this in standard form. We need to talk about that for a minute. Let me move this slope-intercept form up to the top of the board so that we can come back to that step. And let's talk about standard form for a minute. Standard form is the form ax plus by equals c. ax plus by equals c. However, if you think about it, that could be, and now we're not thinking about the problem we're working right now. This is a separate discussion for the moment. If I had the equation, say, 2x plus 3y equals 5. That's in standard form. What if I multiply both sides by 2? Or what if I multiply both sides by 10? These are all equivalent equations. What if I take the opposite of both sides? What if I were to divide both sides by 4? 2 divided by 4, that's 2/4 or 1/2. So here I have equivalent equations. All of these equations are the same line. All of these equations represent, well, let me fix this. Now they do. All of these equations represent the same line. I don't want to be in a situation where I get this for an answer, you get that for an answer, somebody else gets this other for an answer, and then we have to compare and say, hey, did we all get the right answer? So we are going to establish a set of conventions for standard form. Here on page 247, at the top, just under Objective 2, it says many of the linear equations in the previous sections were given in standard form, ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. Okay, we know that from section 3.1. In most cases, a and b are rational numbers. All right. Now she says, for consistency in this book, and this is done not just in this book, but across mathematics. So for the sake of consistency, we're going to give our answers so that a, b, and c are integers with greatest common factor 1, and a is greater than or equal to 0. If a is equal to 0, then b must be greater than 0. All right, let's slow that down. There are 3 conventions here. The first thing she says is we will give our answers so that a, b, and c are integers. A, b, and c are integers. Well, that's not the case if I have fractions. So I would need to clear the fractions from the equation. She then says, with greatest common factor 1. Look at this equation, this second one here on the board. 4, 6, and 10 all have a common factor of 2. I could divide both sides of this equation by 2 and, what I sometimes say, reduce the equation. Reduce it back down to where your 3 coefficients, your 3 numbers, have no common factors other than 1. They can't be reduced down any further without turning them back into fractions. And then she says, and a is greater than or equal to 0. If a is 0, then b is greater than or equal to 0. What does that mean? That means that this leading coefficient has to be what? Greater than or equal to 0? 0 or positive. A has to be 0 or bigger. And if a is 0, well, that just means that we're talking about a horizontal line. Then b has to be positive. So in other words, the leading coefficient has to be positive. Okay, let's make some sense of this. Standard form. ax plus by equals c. Now with these 3 conventions. No fractions. She said the coefficients have to be integers, so I don't want to see fractions in my equation. We also said a greatest common factor among the coefficients of 1. I call that being reduced. Now that's a Fox term. We don't talk about equations being reduced, but it makes sense when we look at it and we say, oh, all of these numbers have this in common, let's divide it out. It's just like reducing. And what else? Our leading coefficient must be positive. For example, if we had the equation 3x minus 6y equals 12, is this in its final standard form meeting all three conventions? No, it's not, because it's not reduced. The 3, the 6, and the 12 are all divisible by 3. So, divide both sides by 3, which we have learned we can distribute. That is, divide every term by 3. To get x minus 2y equals 4. This is appropriate for a final answer in standard form. There are no fractions. It is now reduced, and the leading coefficient is positive. If I had an equation that ended up looking like 1/2 x plus 3/4 y equals 7, is this in its final standard form? No, because I shouldn't have fractions. My coefficients are supposed to be integers. How do I fix that? Clear the fractions. Multiply both sides by the LCD of all the fractions involved. Distribute here on the left. Half of 4 is 2. Plus 3/4 times 4, the 4's cancel to leave 3y equals 28. This is now in a final standard form. There are no fractions. It is reduced. 2, 3, and 28 don't have any factors in common among all three of them. And the leading coefficient is positive. What if I had the equation negative 3x plus 4y equals 6? Is this a final answer for standard form? No, because the leading coefficient is not positive. So what do? Take the opposite of both sides. In other words, and I don't know how you want to say this. Some of us say, let's just take the opposite of both sides. Some of us would say, let's multiply both sides by -1. Some of us would say, let's divide both sides, that is, every term by -1. But the effect is going to be, regardless of which of those three ways you approach it, to change the sign on every term in the equation. Is this now in its final standard form? Yes. Because I have no fractions. It is reduced. 3, 4, and 6 don't have any common factors to divide out. And the leading coefficient is now positive. You need to know this. How to write an equation in standard form with those three conventions in place. If I ask for your answer to be in standard form, we have now agreed upon those three conventions. That in standard form we have no fractions, that the equation is quote-unquote reduced, that is, no common factors among the coefficients, and that the leading coefficient on the left will be positive. Let's return to the problem that we're working. We had already gotten an answer in slope-intercept form, and that's good for part A. Part B says, I also want the answer in standard form. Well, standard form, I want my x's and my y's on the left, my numeric term on the right. So let's take what we have here and subtract x from both sides. Subtract x from both sides. Now it looks like ax plus by equals c, but have we met all three conventions? Well, there are no fractions. It does not need to be reduced, but the leading coefficient is negative. Take the opposite of both sides. And now we have our answer in standard form. Sometimes on a quiz or a test, I won't give you 2 points or a point and a slope. I may just give you an equation and say, now write this equation in standard form. And that's what I'll want to see. Remember our original 2 points for this problem? It's been a minute. Again, very easy to check. If you plug in 8 for x and 5 for y, is this true? 8 minus 5 equals 3, that checks. And what about my other ordered pair? 9 minus 6 equals 3, that checks. And so here are the 2 parts that they asked for. I have my equation in slope-intercept form, and I have my equation in standard form of the line that passes through that pair of points. I think we should do another one. Let's get number 22. So here we go, from the top. We want to find the equation of the line that passes through -1, -7, and -8, -2. I want to give that final answer in both slope-intercept form and in standard form, because that's what the instructions have required. I'd like to plug into point-slope form, but I don't have a slope. If I only had a slope, I'd be in business. We can always find a slope given 2 points. It's the difference in the y's over the difference in the x's. And so we'll plug in. I'll call the first point my first point, the second my second. And having said that, I'll plug in saying -2 minus -7 over the difference in the x's in the same direction, -8 minus the -1. Make some 2 marks there. That's going to be 5 over a -7. So I have my slope, or I might rewrite that with the negative out front, -5/7. I have my slope, and so I'm ready to plug into point-slope form. I have 2 points to choose from, and I have a slope. Point-slope form, y minus y1 equals m quantity x minus x1. I usually pick the point that looks like it's going to be easier to use. I don't know that either of those are easier than the other one, so I'll just grab the first one, the -1, -7, and I will use that as the point that I'm plugging in. That gives me y minus, and the y coordinate of my point that I chose is that -7, equals the slope. We found the slope to be -5/7 times the quantity x minus, and the x coordinate of my point is -1. Let's take a step just to clean that up. Make 2 marks. That's y plus 7. And again, this is x plus 1. So we have an equation for our line. This is an equation for the line that passes through those 2 points. But Part A says, I want this in slope-intercept form. Part B says, then turn around and put it in standard form. Now, if all it asks for is standard form, you don't have to go through slope-intercept form to get to standard form. You can just start manipulating this into standard form. But Part A does say, let's put this in slope-intercept form. That means we want this solved for y. Let's distribute this -5/7. Watch your signs. I guess this did turn out to be a better choice that I chose the -1, -7. Otherwise, I would have had an 8 sitting right here to multiply times that -5/7. So I got lucky this time. Subtract 7 from both sides. Subtract 7 from both sides. We're trying to get y by itself to be in slope-intercept form. So this gives me y equals, the 7 subtract out, negative 5/7 x. And in order to perform this subtraction, or addition, however you want to see that, I need to write my negative 7 as a negative so many sevenths so that I have a common denominator. 7 is how many sevenths? 49 sevenths. Minus 5 of them, minus 49 of them is minus 54 of them. 54 sevenths. And so here's the equation of the line that passes through those 2 points in slope-intercept form. But they also wanted me to give this answer in standard form. Let's make some room. I need to at least. You can continue down your paper. I'm going to move this up to the top where I can see what I'm doing. Okay, so here's our answer that we found in slope-intercept form. But now we want it to be in standard form. We want it to look like this. We want our x's and y's on one side, our numeric terms on the other, remembering that we want no fractions. That we want this to be quote-unquote reduced. And that the leading coefficient is expected to be positive. So what do you want to do first? Some of us would go ahead and get my x's and y's on one side. Add 5/7 x to both sides. And that's fine. Some of us are going to say, I don't want fractions in the end. Let's clear the fractions to get started. And that's fine. Whichever one of those you do first, you're going to do the other one next anyway. I'm going to start this by adding 5/7 x to both sides. Add 5/7 x to both sides. It's now in the form ax plus by equals c. But we have the issue of fractions. So let's clear those fractions. Like I said, you could clear the fractions first and then move your x term over. Either way. Here we need to multiply both sides by 7. As I distribute the 7 here on the left-hand side, 7 times 5/7 leaves just that 5. 5x plus 7y and equals, those 7's cancel to leave negative 54. This is in standard form, meeting all 3 conventions. We have no fractions. The coefficients 5, 7, and negative 54 have no factors in common other than 1. It doesn't need reduced. And my leading coefficient is positive. Make sure you get a handle on writing your answer in standard form. That is one thing you can definitely expect to be quizzed on. Let's finish up with a couple of problems that crank this up just one more little notch. Let's look at number 30. And now we need to think. I mean, there's no step-by-step process that's going to work every one of these problems for me. I have to look at the problem and say, okay, here's what I have. Here's what they've asked for. I have all of these tools, all these blue boxes, brown boxes, these formulas. I have all these tools at my disposal. How do I make it happen? Number 30. In number 30, we're asked to find the equation of the line satisfying these conditions. That my final answer be a line that is parallel to the line 5x minus y equals 10 and has a y-intercept at 0, -2. It says in the instructions, give your final answer in slope-intercept form. I want to find the equation of a line such that it is parallel to the given line and has a y-intercept of 0, -2. Well, I've got a y-intercept if I only had a slope. Easy enough. If my line has to be parallel to the given line, then my line will have the same slope as the given line. What is the slope of that given line? I've shown you two ways to find it. We could just solve it for y. Subtract 5x from both sides. And then to get y by itself, take the opposite of both sides. So the slope of the given line, slope sub given, the slope of the given line is 5. Well, then the slope of my line, which is the slope parallel to the given line, will also be 5. And now this one is very slick. We're pretty much there. I'm not going to plug into point slope form this time, although I could, it would work. I have a point, I have a slope. But the point I happen to have is a very special point. It's the y-intercept. I have a slope and I have a y-intercept. How about we plug into slope-intercept form? Y equals the slope of my line is 5, and the y-intercept, the y-coordinate of the y-intercept is -2. And it just so turns out that we were asked to give our answer in slope-intercept form. So we're done. This equation is the equation of the line that is parallel to this given line and that has a y-intercept of 0, -2. Let's try number 32. In number 32, I want to find the line that passes through the point 4, 2 and is perpendicular to the line x minus 3y equals 7. First of all, I do know how to spell the word through, but we're just taking notes. So I'm using this informal method. I don't want you running to your English professor saying, hey, guess what Professor Fox is doing? That's just for note taking. On a quiz or a test, I'll spell it out. Okay, let's think about what we have, what we need, and how we're going to get there. We need to find the equation of the line that passes through that point and is perpendicular to the given line. Well, I have a point. If I had a slope, I could plug into point slope form. I can get a slope because knowing that my line needs to be perpendicular to the given line, if I knew its slope, I could figure out my slope. Let's find the slope of this given line. Now, in the previous problem, I solved for y, and you're welcome to do that again. But also remember that when an equation is given in standard form like this, perhaps the quickest way to find it is using this blue box that I gave you, -a/b. So the slope of that line is going to be negative. A is 1, the coefficient on x, 1, and b is -3 for a positive 1/3. Okay, this is the slope of the given line. I need to figure out what is the slope of my line, the one that I'm trying to find. Well, it's going to be the slope that is perpendicular to the given line. Perpendicular slopes are what? Opposite reciprocals. Change the sign and flip it over. There's my slope. I have a point and I have a slope for my line. I'm ready to plug into point slope form. Y minus the y coordinate of my point is 2 equals the slope of my line is -3 times the quantity x minus, and the x coordinate of my point is 4. We have an equation, but we were instructed to write our final answer in slope-intercept form. So get this solved for y. Let's distribute that -3. Watch your signs. And add 2 to both sides. Add 2 to both sides. And here's my equation of that line in slope-intercept form. If I had been asked to write my answer in standard form, this one's very quick and easy. Add 3x to both sides. This is if I had been asked for standard form. I wasn't. I'm just throwing that in there. But here's our final answer to number 32. This is the equation of the line that passes through the point 4, 2 and is perpendicular to this given line. I would encourage you to graph this line, graph the given line on the same coordinate plane, see that our line does indeed pass through the point 4, 2, and if it's a nice, neat picture, it should appear that my line and the given line meet at right angles. Something to try, something to think about. That concludes our look at Chapter 3. Get lots of practice on this material. If you want extra practice, holler at me for the even-numbered answers so that you have more of these problems to do. Because your homework, we're not doing the word problems from this section. We're going 5 to 33, the odd. And so I'll let you get started on that.